me show you this other graph. This also comes from the Wikipedia article. And in here, the interesting thing to note is there's two dimensions for this graph, to read the graph. So here we have from the center of the Earth, so let me get the pen. So this would be the center of the Earth to the surface of the Earth, about here, all right? So in kilometers, the radius of the Earth from the center to the outside. So there's about 6,000, close to 6,300 kilometers, all right, of the radius. And then this other part of the graph shows the density of the material at the different layers of the Earth structure. But now we are talking about the Earth crust, and you can see that the Earth crust is getting more dense. And then there are these areas here where there is a jump in density. These are what is called the discontinuities. So there is a part where the different layers meet, where the density of the material changes all of a sudden. Okay, and then you have a pretty uniform set of density for all that part. So this thin layer here, this is the lithosphere. Then you have a discontinuity at this point. It's called the moho layer, and that is because of the name of the guy that discovered it. Okay. It was a much more complicated name to pronounce. It was a Croatian name of the guy, so we just call it the moho discontinuity between the lithosphere and the crust. And so this part here is what is the crust, the density of the crust and the depth of the crust. So the depth of the crust goes from about right here, okay, to all the way to this area, all right? And then you see there's another discontinuity, another jump between the crust and the mantle. Okay, can you see the change in density here between the crust and the mantle? There. And then the mantle is pretty uniform in density. It increases in density as it goes deeper. And then right about here, okay, at about 3,500 kilometers, we have a huge change in density, a huge discontinuity between the mantle and the core. And then there's another discontinuity of density between the outer core and the inner core.
Why does it jump so fast in density instead of gradually? Like, why doesn't it go gradually, like just as much as you get gradually more weight on it, the more further down you go, but instead it goes all of a sudden different density?
That is an excellent question, Rodney. Excellent question. And the reason is pretty much the same as, have you ever put in a jar, on a cup, you put water and oil?
Yeah.
What happens when you put water and oil?
The oil floats.
The oil floats. Okay, why?
Because it's out of a lighter density than water.
That's right, because it has a high, it's lighter in density. Okay, well, so if you were to measure in this, let's say that we do this same graph here between water and oil, so you would have the same type of thing where you have the density of oil, okay, the density of oil here, and it would be the same density, all the part of oil, and then there's a huge discontinuity between the water, and then you have the density of water.
So what?
Can you see that the layer, the part there, right there between water and oil, you have a discontinuity.
So really,
a jump.
Elements change all of a sudden.
Very, very much. They change a lot, okay, in density. So the density of the mantle is a lot different because it's a lot lighter than the density of the core. Okay. So you really can see how this, because of the changes in density, you really see that all the different layers are really floating on each other, floating on top of each other. Isn't that amazing?
Yeah, I was just thinking, like, how did these things become in order so perfectly?
Because of weight.
Because of weight.
The heavier they are, the deeper they go into the earth. They sink.
Do we know what these elements are then?
Yes, of course. Of course. So the core is metallic. Okay. So they are heavy metals, iron, nickel, gold, and all the heavy metals, they sunk down into the core. The mantle is basaltic, okay, so it's more rock, and so you have different, and then the crust is even lighter rock.
And yet we somehow still have a lot of metals on the crust.
Yes, thank goodness we do, because that allows us to do mining and everything. Okay, but I don't know if you remember when we were talking with Dr. Lewis about the asteroids, he was mentioning that one of the things that are important about asteroids is that because they are not very big, they don't have enough gravity to pull the heavier metals inside into the core. And so it's actually easier to mine heavy metals in an asteroid than on the Earth. Because on the Earth, the heavy metals have sunk for the most part.
It's big.
Yeah, yeah. So imagine that how big this is, that all the mining, all the things that we have done, okay, all our activity is has always been in the lithosphere. We haven't even done anything to get to the crust. Okay.
We haven't even touched the crust.
No, that's right. So there have been some projects to try to get here to the Moho discontinuity, and they have not been able to get that deep.
That's really deep.
Yeah. But imagine this is just this deep, okay? That is this difference in depth, all right? This little part. Okay.
Earth is huge.
This is a huge world. All right. So sadly, our time has gone. Okay, but I think that we have touched on a lot of very, very important things here today. Okay, we've talked about the pressure and how these materials sink and the density. All right. So I want you to look there in Wikipedia. Yeah, time flies when we are having science class. Yes, I tell you, really.